Alright guys, so today we are looking at angles formed by parallel lines. So a continuation on what we started in with lesson 2.1. So last time I mentioned to you guys that you might want to keep kind of like a vocab page together so that you can keep track of what all the justifications are for the different types of relationships that we see between angles. And so I've kind of made a little bit of, this is a very rough one that I just really quickly made up, but I made something kind of like that here. I probably would have organized it a little bit better if I was doing it for myself to study. But just a reminder of what we looked at last time. So we talked first of all about supplementary and complementary angles. So these are angles that add up to different number values. Supplementary angles, so for example A and B here, add up to 180. Complementary angles add up to 90, so A and B together are going to equal 90. We also looked at alternate interior and alternate exterior. Remember, alternate just means on the opposite side of. So, and when we're talking about that, we're always referring to the transversal, which is the line that cuts through these two parallel lines. So we have a transversal here. And interior is referring to the parallel line. So the alternate part is referring to the transversal, the interior part is referring to the parallel lines. And so basically all we're saying is alternate on the other side of the transversal. So you can see these two angles I've drawn in here are on the opposite sides, and they're on the interior of the parallel lines. So that means if our two parallel lines are here, we're going in from them. Okay, alternate exterior refers to parallel lines, so we're moving outside of them because they're exterior, and then it's still angles on opposite sides, so these two would be alternate exterior. Now, of course, I've only drawn in one example, I guess, two angles. You could also say that this angle here and that angle there would be alternate exterior. Okay, and same thing for alternate interior. You could also use these two instead of these two. Okay, now the only other one we looked at last time is corresponding angles. And remember, with corresponding angles, corresponding again is referring to the transversal, so they're on the same side, corresponding side of the transversal. Okay, and but they're not on adjacent. They're not going to be adjacent angles because that would be supplementary, right? They're going to add up to 180. So here we can see, and they're going to be equal angles around these parallel lines. So if this is the angle we're looking at, then one of its corresponding angles has to be on the same side of the transversal, and it has to be an equal angle. So if it's the next one that would be corresponding would be this one here. Okay, if we would have used this as our reference angle, then the corresponding angle would have been here. If we would have used this as our corresponding angle, or as our reference angle, I guess, then this would have been our corresponding angle. And if this was our reference angle, then that would be our corresponding angle. Okay, so lots of different options, but just a quick reminder of what those different justifications were that we looked at last time. So I've kind of given a little bit of a repeat here on alternate interior and alternate exterior angles. So just a quick reminder, if you can think of, and I kind of just went over it for you here. So let's say if we're looking at angle C here, can you think of which one is going to be alternate interior? If you guess F, you are correct. What about if we were looking at angle D? Then it's its alternate interior would be angle E. Okay, now keep in mind you can have alternate interior angles on non-parallel lines, so these two lines are not parallel, but so you have these two, you have alternate interior. So for example here, if we looked at angle C, then we would have angle G would be its alternate interior. However, they're not going to be equal in that case. Okay, sorry, I filled that one in a little darker. Same thing with, you could say that D here would be 1, and then E would be its alternate interior, but you can pretty clearly see that the angles are not equal there. Okay. Same thing for alternate exterior. So see if you might want to pause the video a second, see if you can pick out what are the alternate exterior angles. Okay, so you should have picked A is an exterior, so which one matches that? Well, it has to be on the opposite side of the transversal and on the exterior of the parallel lines. Okay, same thing here. G is on the outside, and on the opposite side on the outside is B. So there's another alternate exterior. Okay, so again, we could look at, for example, here A, if that was our first exterior, then the alternate exterior would be over here, opposite side of the transversal. But again, you can see pretty clearly that those angles are not equal because the lines that the transversal is intersecting are not parallel. And then here's our other option, would be B and F, or alternate exterior. Okay. Yeah, so that's just a little bit of a recap from last time. So let's go through an example where we have to prove a conjecture. So basically a conjecture is a statement, and then we have to use properties of angles to basically justify whether it's true or not. So the conjecture is that when a transversal intersects a pair of parallel lines, the alternate interior angles are equal. So what they're asking for us for is basically to prove that that would be true. Okay, so the first thing that we can look at here is we're trying to prove that the alternate interior angles are equal. Okay, so the first thing that I looked at when I did this is I looked at corresponding angles, because that was one of the proofs that we already had. So basically I looked and said, okay, based on the rule of corresponding angles, and just keep in mind, you might come up with different ways of doing this. This is not the only correct way. Okay, so what I said as my first thing was that angle 1 and 2 have to be equal because they're corresponding, right? So I have a transversal here, they're on the same side between these two parallel lines. And because that's not what I'm not trying to prove, like I couldn't have done, for example, 4 equals 5, because that's using the alternate interior angle justification, and I'm trying to prove the alternate interior angle justification. So even though there's more than one way to do this, you could not do that. So if you're proving a certain like justification, you can't use that justification in your proof. Okay, so angle 1 and 2 are equal, and we know that because of the rule of corresponding angles. All right, so I jumped ahead a little bit there because I had to pause the video because my phone rang. So corresponding angles on parallel lines. So if we know angle 1 is equal to angle 2, what other angles can we kind of figure out? Well, for one thing, we know that angle 1 and angle 4 are supplementary, right? So that means they have to add up to 180 because they are on a straight line. And we also know that angle 3 and angle 4 would have to add up to 180 because they also form a straight line. So we can say angle 1 plus angle 4 equals 180 degrees. And we can also say angle 3 plus angle 4 equals 180 degrees. Now this is due to the fact that they are supplementary, right? Supplementary. And you might be wondering, how does that help us to prove alternate interior angles, right? Well, let's think about what some of our alternate interior angle options would be. Well, we have angle 3 and angle 2 would be alternate interior, or angle 5 and angle 4. So we're trying to prove that alternate interior angles are equal. So basically we know that angle 3 and angle 2, if these lines are parallel, then angle 3 and angle 2 should be equal, and so should angle 4 and angle 5. Right now we know angle 1 and angle 2 are equal to each other, right? But if we could say that angle 3 and angle 2 were equal, that's really going to be our proof. So basically what we're going for here is, now if we know that angle 1 and angle 4 add to 180 and so do angle 3 and angle 4, what does that tell us about angle 1 and angle 3? Well, if they both get added to the same number, like so angle 4, and equal the same value, then angle 1 and angle 3 have to be equal, right? Because 1 plus 4, which is going to be a constant number, equals 180. 3 plus 4 equals 180. 4 is the constant number. So then we can say that angle 1 has to be equal to angle 3. Now this is a property that we actually haven't really looked at yet. I should have maybe introduced that already. You'll find it in the summary at the end of this lesson. It's called the transitive property, which is where we could say, like, for example, if A equals B and B equals C, then A has to equal C, right? Because let's say if A is equal to B and B is 2, and then 2 is, so B is 2 and 2 is equal to C, so then C is 2 as well, and A has to be 2, so then A is equal to C. So this is the property of equality. And we can use the same idea here, which is where we can say, because angle 1 equals angle 2, and we know that angle 1 equals angle 3 because of this property here of the supplementary angles, we can say that 1 has to be equal to 3 then as well. Or sorry, we can say 1 equals 3 because of this part here. And then in the end, that's going to allow us to say that if 1 is equal to 3 and 1 is equal to 2, then 3 has to also be equal to 2. So that's where we're going to get to our end point here. Now, both of these kind of components actually end up being a little bit of the transitive property. So angle 1 is equal to angle 3. Technically, we can call it transitive. It's a little bit different than the kind of like context we would normally use it in, but I can like kind of write in here. Let's see, what could we put in? Angle 1 and angle 3 both add with angle 4 to equal 180. Okay, and then because of that, maybe next time I make these notes, I'll actually put a separate box here because it's a little bit separate. So now I would say angle 2 has to be equal to angle 3, and that is due to what we call the transitive property. Which is basically saying that if 1 is equal to 3 and 1 is equal to 2, then 2 and 3 also have to be equal. Okay, so basically we've just proven that these angles are equal with each other, which is what we were trying to do, alternate interior angles being equal. Okay, so let's look at another example here. So determine the measures of A, B, C, and D. Provide a justification for each. Okay. So we have A, B, C, and D. So usually when you're working with something like this, you want to first think about what do you know here? Well, we have this 110 degrees here. So is there an angle we could easily relate it to? Well, if if this 110 is here, the nice thing with this diagram actually is that these two lines are parallel and these two lines are parallel. So you can kind of use either one as a transversal. So if we considered this to be a transversal, 110 here is on the interior. So if we wanted to use alternate interior, we would figure out this angle. Okay, but that doesn't really help us directly right away, so maybe let's forget about that one for now. The other thing we could look at is, well, if we look at 110 here compared to B, what would that relationship be? We're going to assume in this case that this is our transversal. We can see that these are our parallel lines. Both B and this 110 degree measurement are on the exterior, and they're on opposite sides of the transversal. So that would be alternate exterior. So we could say B is equal to 110 degrees. And the reason for that is alternate exterior. Angles. Okay. Sometimes we want to, on parallel lines, I guess we should specify that. Okay, so now we know B. What else can we figure out here? Well, angle A here is on the same side of the transversal as the 110, and you can see that they are corresponding angles, right? Because they're on non-adjacent angles, and you can see that the similarity, right? This one is greater than 90 versus this one is less than. So we can say A is equal to also 110 degrees. And the reason for that, a little bit different than B, is corresponding angles on parallel lines. Okay. All right, so now we need to jump over here to C and D. Now we know A and B, so let's take a look at what some of these relationships could be. C here, which angles would it have a relationship to? Well, it could have alternate interior, right? So it's an interior angle, so it would have a relationship with this angle here. Or, let's see, corresponding would be here, which we don't have a measurement for. And that's basically the only proofs that we have right now. So regardless of whether we use this angle here or that angle there, we are going to have to solve for one of those values. So how could we do that? Let's say we're going to use this one here. Okay, so that we can then use our alternate interior. How could you solve for the value of this angle? Well, you can either use angle B and say that it's going to add up to 180, so they're going to be supplementary, or you can use angle A. It doesn't really matter because they're both the same value. So let's go with angle B. So let's call this one, just so we have a reference for it, let's call it angle X. Okay, so angle X plus angle B are going to equal 180 degrees, which means that angle X is going to be equal to 180 degrees minus B, which is 110 degrees. So that is going to be equal to, oh, I'm running out of room, 70 degrees. Oh, I don't like that. Sorry, guys, I'm being too nitpicky. There's no good way to write that. I started out wrong there. Equals 70 degrees. I'll put it in right there. Okay, so we can say that that is due to the property of supplementary angles. Okay. All right, so now we know that this one is 70, and so now we can figure out C, right? Because we know that these are alternate interior. So angle X equals angle C, which equals 70 degrees, and the reason for that is alternate interior. So hopefully, again, you can see that there would have been more than one right way to do this, just so long as all your proofs line up. Okay, so our last angle we need to prove is D. We have angle C. What is the relationship between angle C and angle D? Well, they're on opposite sides of the transversal, and they're on the insides of these parallel lines. So again, we see that we have this property of alternate interior, so we can say angle C equals angle D, which equals 70 degrees. And again, we can kind of say alternate interior angles on parallel lines. I'm just going to do quotes there to show that it's a repetition of the one above. Okay. Let's try another example here. So with this one, it was looking for angle measurements. So that you're going to encounter kind of regularly two different types. Ones where you're looking for the different measures, or ones where you're trying to prove something. Like, for example, that lines are parallel is a pretty common one. So in this one, it's asking you, one side of a cell phone tower is built as shown. use the angle measures to prove that CG, so this line here, BF, and AE are parallel. Okay, so let's just start out by, especially with drawings like this, it can be helpful to be really clear with what it is that you're trying to solve. Okay, so those are the ones I'm trying to prove are parallel. The way that I can start out with doing that is try to prove that one is parallel to the other. And again, there's multiple different ways. So there's an example like this in the textbook, and they have a different way of solving it. So I'll just go through, at least I think it was different than my way. I don't know, I didn't look super carefully, but I'm pretty sure it's different because it would be unlikely that we would both come up with the same thing independently. So AE is what I started with, and I wanted to prove that it was parallel to the one next to it. And the reason why I chose to start with that one is because I could already see that these angles are filled in, and this you can tell is kind of like a transversal here. So this little angle coming down there, right? Because we want to try and prove these two are parallel. We have a line that's intersecting them at two different points. And the nice thing that I could see here was that I had two equal angles. And the relationship between those angles is that they're on the insides of the parallel lines, right? So here's my parallel lines. The 22 degrees are on the inside, and they're on opposite sides of this transversal. This one is between here and here, and then if you flip over to the other side of the transversal, the 22 degrees is there. So basically what I said is AE is parallel to BF. Now you'll notice that the statements and justifications are a little bit different in these types of questions as well. So when you're trying to determine the measures, you're basically figuring out the calculations to come up with the numbers, or just stating what the angle is equal to, because that's what you're trying to prove, right? So it's always the thing that you're trying to prove that you put into the statement, and then the justification is like one of the properties that we've looked at. So here we can say AE is parallel to BF, and the reason we can say that is because this angle AEB is equal to EBF, and that shows us that it has the property of being alternate interior angles. So AEB is equal to angle EBF because of alternate interior angles. I'm just going to leave it as alternate interior. Okay, so now we know that AE is parallel to BF, or we can show that. What else would we want to prove? Well, I also wanted to prove that AE is parallel to CG. That was the next one I did. You could try and prove BF parallel to CG first, but for whatever reason I chose to do it this way, so I did first AE and BF, then AE and CG. And so if I'm trying to prove that these two are parallel, so I can say my statement is going to be AE is parallel to CG. Okay, and why do I think that that's true? Well, the reason that I came up with is because this DCG angle here, which is 78, is equal to BAE down here, which is also 78 degrees. And so essentially what's happening here is I have my transversal kind of a line cutting through my parallel lines AE and CG. And on the same side of the transversal, I have on corresponding angles, I have equal values of 78 degrees. So I can say angle BAE is equal to angle DCG because of corresponding angles. Okay, so now my last proof has to include this BF one. And so all I can say here is that if AE is parallel to BF, and AE is parallel to CG, then BF also has to be parallel to CG. And if you can remember what the name of that property is, we haven't covered it super well yet, but we looked at it in the previous page. If one thing is equal to another, so for example, if this is parallel to that, and this is parallel to that, then this one also has to be parallel to that one. Okay, so that is called the transitive property. Okay. All right, so let's look at a quick little summary of basically all the different proofs we have looked at here. So with parallel lines, we have the following proofs that we can use. So if you have a transversal that intersects two parallel lines, then these are the following things that will be true. The corresponding angles will be equal. The alternate interior angles will be equal to each other. The alternate exterior angles will be equal to each other. And the interior angles on the same side of the transversal are supplementary, right? So down here I kind of have an example that we'll go through with this. So interior angles on the same side of the transversal, right? So B and F are supplementary. So that means they're going to add to 180. Okay, and this is a little bit of a new component that we haven't looked at yet. Now the other side of this proof box is basically saying the same thing but in reverse, because here we're trying to say, like, if a transversal intersects two parallel lines, these facts will be true. This one is trying to say two lines that are intersected by a transversal are for sure parallel if, and then basically the proofs are the same. So this one is saying you have a transversal intersecting and therefore these angles will be equal. Here you're saying if these angles are equal, or if these facts are true, then we know that those lines have to be parallel, the two lines that are intersected by the transversal. Okay. So maybe before we move on to the other proofs, we'll go through this example. So if we wanted to look at part number one, the corresponding angles are equal, right, which is true for both of these. Which ones in here are corresponding? Well, there's a whole bunch. So if we start on this, actually let's start on the top side here. Let's start with A. What would be a corresponding angle with A? Well, it's going to be on the same side of the transversal and a non-adjacent angle. So it's going to be A is equal to E. Okay. And then if we move along to C would be equal to G, right? So same side of the transversal. If we move to the other side, B is going to have a corresponding angle of F. And so according to rule number one here, that means that they're going to be equal. B will be equal to F, and then D will be equal to H. Okay, so those are all of my corresponding angles. Corresponding. Okay, the second proof involved alternate interior angles. So if we look on here, which ones are alternate interior? Remember, interior means they need to be on the inside of these parallel lines. So if we start with C, for example, then the one that would be on the interior but on the opposite side of the transversal is F. So we can say C is equal to F. And then the other interior set would be D and E, and they're on opposite sides of the transversal. So we can say D is equal to E, and both of those are going to be alternate interior. Okay. Property number 3 is alternate exterior angles are going to be equal. So on the outsides here, let's start with A again. And what would be its alternate exterior? Well, it has to be on the other side of the transversal and on the outside of the parallel lines. So it's going to be A is equal to H. And the only other one would be B is exterior, and it's going to be equal to G. So those are my alternate exterior. Okay, and then I didn't end up adding in 4 down here, but we can do that really quickly. So the interior angles on the same side of the transversal are supplementary. So interior on the inside of the parallel lines, and they're on the same side of the transversal. So according to this property, we would say D plus F equals 180 degrees. And we could also say C plus E equals 180 degrees. Okay, so those are like looking at an example like this, you can see all of these different proofs for the fact that the lines are parallel and that those angles are equal. Other proofs we use, the transitive property, hopefully you kind of have that somewhat figured out, but basically we could say with the transitive property, for example, we could say if A and E are equal and E is equal to D, right? So we have here, using proof 1, we said A and E are equal. Here, using proof 2, we said D and E are equal. Then that tells us that we can say A and D must also be equal. So I'll maybe write that out down here really quickly. So transitive. So A and E, or A equals E, according to property 1. D equals E, according to property 2. So then we can say, so I don't know if you guys are familiar with this shorthand, but usually if you're saying therefore, then you draw a little triangle with 3 dots. So therefore, angle A is equal to angle D. And that's the transitive property. Transitive property of equality. Okay, now the last thing I have here is opposite angles, which we haven't looked at all yet. So this will be an introduction that we can use in our next section. So with the opposite angles, basically what happens is if you have angles that are on opposite sides of intersecting lines, they're going to be equal. Okay, so basically if you have an X, then the angles that are across from each other in the X are going to be equal. Same thing here, if we did angle C and angle D, then we would say C is also equal to D, right? Because they're on opposite sides of the X. Okay, and so the name for that proof is opposite angles. So you'll want to add that to your list. Everything else we have was already on there. Transitive is kind of hard to put on there because it's just the equalities, but I can put on, let's see, opposite angles. Opposite angles. I can add that to my kind of reference sheet I'm making up here of different justifications. Okay, so let me see here. That is everything for 2.2, and next time we're going to be kind of starting to apply this to triangles. So we're going to be looking at angle properties in triangles. So I will see you then.